Hey friends, welcome back to the channel. So in this video, we're going to be covering the differences between monolithic and microservice architecture, and more importantly, which one you should be using in your next project. Each architecture has its own pros and cons, so hopefully by the end of this video, you'll understand which one you should be using. So what is a monolith? Before we had microservices, everything was built as a monolith. A monolith is an application where everything works as one piece of code. It's usually the starting point for any new application, whether that be an API or a front end, and you usually end up with one executable in one repository. Your application is then developed, deployed, and scaled as one single component. If you're working in a team on the same application, you need to make sure that you don't step on each other's toes. Anyone who has had to work on a big code change all in one sitting, such as a big refactor, will know the pain of having to merge everyone else's changes into your code. Now, before we go and cover the problems with monoliths, they do have a number of key advantages over microservices. First of all, monoliths are really easy to develop. All your code is in one place. You don't have to worry about checking out lots of different repositories. And when it comes to actually test your application, you only have one application to worry about. If you're working on a small application, then this makes a really big difference in the time it takes to develop. Most applications do start as monoliths simply because it's a lot quicker to get them to market. Number two, monoliths are really easy to deploy. After all, you've only got one application to worry about. On top of that, you only have one CI/CD pipeline and one infrastructure to worry about. Number three is that they're easier to debug. If you've only got one application, then you've only got one place that you need to look if there's a problem. The real benefit comes when you come to debug your application locally. Stepping through one application is a lot easier than having to step through multiple. And if you're running multiple applications, you need to make sure that they're all running on different ports. The last advantage of monolithic architecture is around performance. Now, I won't go as far to say that monoliths are more performant than microservices. However, with a monolith, you don't need to worry about latency. If you only have one application, then there's going to be negligible cost between the different parts of your code calling each other, which we'll see with microservices gets a bit more complex. So if monoliths are so great, then why should we bother with microservices? Despite the benefits, monoliths do come with some glaring issues that usually cause teams to move to microservices further down the line. The first is that monoliths tend to get really big. After all, if you've only got one application to stuff all those features in, it's going to get bloated over time. Every developer starts with good intentions and applies clean code practices to make sure that their application is easy to maintain. But even the best designed application starts to look like a giant mess once it reaches a certain size. If it takes over a month to onboard a new developer to your team after explaining all the different parts of your application, then chances are you need to look at other options. Number two is that your release process is taking too long. If your application has lots of different features, then that's a lot of different things you need to test before each release. As your application is just one big component, even the smallest of changes requires you to release the whole application each time. Depending on your application and the maturity of your CI/CD pipeline, it can take a lot of time to do a release, especially if you need to worry about switching traffic between green and blue services as well as monitoring the logs. Lastly, the main problem with monoliths is that they're really difficult to scale. If one part of your application is getting a lot of traffic, then you have no choice but to scale up the whole application. This either means spinning up more instances of your API or beefing up the CPU or memory of your server. Either way, it's going to cost you a lot of money because your application is so large. Now that you've seen all of the disadvantages of monoliths, especially as your application gets bigger, we can have a look at the solution, which is of course microservices. With microservices, we take your big monolithic application and break it down into individual components. Each component has a single responsibility and is usually in charge of a single business functionality. If you take Netflix, for example, they might have one component in charge of search, another one in charge of streaming videos, and another one in charge of the recommendations. Each service is self-contained and independent from all the others. They all have their own infrastructure and their own database, for example. Each microservice is its own application, it has its own version, and it's released separately from all the others. If you split your application into microservices, how do you get them all to talk to each other? Well, there's three main ways that microservices can communicate. The first is by API. Each microservice has its own endpoint that the other microservices can call. This should be used when you need synchronous communication between your components. Microservices usually have a health endpoint as well to make sure you can ping them so you know that they're still operational. As with all HTTP requests, this is going to introduce some latency to your application that you need to take account of. However, you can use things such as gRPC and compression to speed up the communication. The second option is to use a message broker. If what your application needs to do can be done asynchronously, then you're better off using a message broker to do this. For example, if your application needs to send an email, it's not usually important that your application gets a response from the SMTP server. It's much easier just to put that message on a message queue and have your application carry on doing what it was doing. You can then have a microservice that listens to that message queue, picks up the message and sends it out as an email. There are quite a few queue-based technologies out there, but the most popular ones are things like RabbitMQ or AWS SQS. The last option is what we call a service mesh. A service mesh handles all of the communication as well as dealing with the discoverability and the reliability of your services. Obviously, no one would use microservices if they didn't have a key number of benefits over the monolithic design. A well-designed microservice is only responsible for one thing, and as a result, they're a lot easier to maintain. In many cases, you might not need to touch a microservice at all. If you take the email microservice that we mentioned earlier, the chances are that the requirements aren't going to change for that microservice. So it's just going to carry on running, doing what you programmed it to do without you needing to make any updates. Compare that to a monolith where you're redeploying your application with every single change. Then you're adding the potential for something else to go wrong in another part of your application. As you only need to deploy a single microservice when you change something, the other microservices are unaffected. As a result, your application becomes more reliable as there's less chance that your whole system is going to come crashing down because of a problem with one component. This is why if you look at outages such as GitHub, it's very rare that the whole system comes down. It's usually just one or two functionalities that are affected. It might be webhooks that stop working or you can't commit your code. But it's very rare that the whole application will go down unless it's an infrastructure issue such as a DNS failure. The next advantage of microservices is that each team can pick their own technology stack. Now this can be a bit of a blessing and a curse. Some languages are more suited to particular tasks than others. Take machine learning for example, you're much better off writing that in Python than you are, say, C#. However, if teams have completely free reign over their own technology stack, then you can end up reinventing the wheel every time you create a microservice. It's much more efficient to use the same technology stack for all your microservices and only deviate when it makes sense to do so. Being able to have multiple teams working independently on the same application is one of the big selling points for microservices. The next advantage from microservices is around scalability. As we saw with monoliths, if you have one part of your application that's getting more requests, then you have no choice but to scale up your whole application. But at least if it's a microservice, then you can scale up that one microservice and therefore save you some money in the process. Lastly, if you want to get to the point where you're releasing multiple times per day, then you need to make sure that each change can be easily tested and automated. If you're working on a monolith, then this is really difficult to do, as even the smallest change can impact a whole application. However, with microservices, your change is limited to a small component, which can easily be tested and deployed independently. It's not all good news for microservices. There are a number of disadvantages that you need to be aware of if you're planning on using it in your next project. If your microservice is highly dependent on other microservices to work, then it's going to be really difficult to run your application locally when you need to do development. You can either resort to mocking out all of the other endpoints, or you have to then spin up Docker containers for all of the different microservices. It can be done, but it is just a bit harder to do than running a single application. Microservices are also harder to debug. When you have a problem in production, you have to look over multiple different services to work out where the issue originated from. This is why it's important to have good monitoring in place when you're using microservices, so you know when a particular component is down or not behaving correctly. This is where using a service mesh comes in handy. Now, I mentioned earlier how microservices can save you money on infrastructure, but that only really happens when your application is trying to scale. If you've got a small application, however, then you've got a lot of infrastructure that you need to pay for that you didn't need before with just one application. If your application is large and you have an uneven distribution of requests, then it usually is cheaper than trying to scale up a monolith. If you've got a small application, then you're going to see an initial large cost on infrastructure when using microservices. Lastly, microservices increases complexity of your whole system. It makes your infrastructure more complex, you have multiple CI/CD pipelines to deal with, and you also need to worry about the communication between your services. On top of that, you need to have good monitoring in place so you know what all your microservices are doing. This might not seem like a big deal when you only have a handful of microservices, but once you have hundreds, it can become an operational nightmare. Now we've gone over the pros and cons of each of the architectures, so which one should you be using in your next project? If you're starting out with a brand new application that isn't going into any existing infrastructure, then I recommend starting with a monolith. There's no point in trying to solve for scaling problems that you just don't have yet. If you're in startup, then your main concern should be trying to get to market as quickly as possible. You can deal with the scaling problems when you actually have them and you actually have some paying customers. Most applications, even Netflix, started as a monolith. It was only once they needed to scale that they decided decided to split things out into microservices. There is one scenario where you should probably start with microservices, and that's if you're hooking into an existing workflow. If you know your application is going to get a million requests from day one, then you need to plan accordingly. In that case, it's usually better to start with microservices, or at least a semi-monolith with key components broken down into their own services. Once your application is live, you can see if it makes sense to break down that semi-monolith into multiple microservices. This is actually how I would look at breaking down a monolith into a microservice. Have a look at your monolith and see which components would make sense to run by themselves. Look at which parts of your application are having scaling problems and which ones can be run synchronously versus asynchronously. If you're not sure about what architecture you should be using for your microservices, then you need to watch this video on hexagonal architecture. Thank you for watching, and I'll see you in the next video.